Hi, mathematicians. So this is our next day of working on perimeter. And remember, we know the perimeter is the measurement on the outside of a shape. And think about, how do we solve the perimeter? Do you remember what we do? We're going to add all of the sides together. That is how we get the perimeter. Well, I'm going to have you go back in your time machine and think about another math word that we've talked about before, area. So today we're going to talk about and think about this question. Can rectangles have different areas but the same perimeter? So remember, the perimeter is the outside, and then the area is the inside. Do you remember how we solved to find the area? All right. Well, if you need a refresher, this video is going to help us out, and then we will go from there. So let's go ahead and think about that question. Can a rectangle have a different area but the same perimeter?
Rectangles have different areas but the same perimeter. Let's find out. Beth, Marcia, and Nancy build rectangular pens for their rabbits. Each pen has a perimeter of 12 feet. Which rectangular pen has the greatest area? What information are you given?
All right, so if we look at our shape, what do we know? They've given us the lengths of the sides. So with that information, we can solve two things. We can solve the perimeter because we know with rectangles, the opposite sides are the same length, right? And we know down here, we've got a square. And we know with a square, all four sides are the same length. So the information that they provided for us, we will be able to find both the perimeter and the area because they've given us the side lengths.
You are given the dimensions of 3 different rectangular pens. What are you asked to find? You are asked to find the rectangular pen with the greatest area.
Drawings help you see how the rectangles are similar and different.
Let's look at Beth's plan for a pen. Find the perimeter. P equals 5 plus 1 plus 5 plus 1 equals 12 feet. How are perimeter and area different?
So we talked about that. Remember, the perimeter is going to talk about the outside of the shape. That's where we got our 5 plus 1 plus 5 plus 1. The perimeter is the outside. The area is going to be what is inside. And if we count, how many blocks do we have? 1, 2, 3, 4, 5. They're going to show us and remind us how to solve for area. But if you remember, we just do 5 times 1. We multiply the two sides together.
Perimeter is a measurement of distance around a figure. Area is a measurement of the space inside a figure. To find the area, multiply the number of rows by the number of square units in each row. A equals 1 times 5 equals 5 square feet. Beth's pen has an area of 5 square feet. Next, look at Nancy's plan for a pen. Find the perimeter. P equals 4 plus 2 plus 4 plus 2 equals 12 feet. Find the area. A equals 2 times 4 equals 8 square feet. Nancy's pen has an area of 8 square feet. How does the area of this pen compare to the area of the first pen?
So stop and think about that. So remember, for the area, we multiply the two sides. So the area for the first pen was 5 times 1, which equals 5. The second pen, we would say 4 times 2, which equals what? 8, right? And remember, our question is we're trying to find the greatest area. So think about that. If this first pink rectangle has an area of 5 feet, and the second rectangle has an area of 8 feet, which one's greater?
The area of this pen is greater than the area of the first pen. Now, look at Marcia's plan for a pen. Find the perimeter. P.
Right, I want you to think about the perimeter. Think about what are we going to add if we know that a square has all the same length sides. Think about that.
E equals 3 plus 3 plus 3 plus 3
Is that what you got?
12 feet. Find the area. A.
So think about how we solved the area. Remember, we're multiplying. So what two numbers are we going to multiply and what would the area be? Think of that in your head as we play the rest.
8 equals 3 times 3 equals 9 square feet. Marcia's pen has an area of 9 square feet. Marcia's pen has the greatest area. Why are the number of rows and the number of square units in each row the same? They are the same because this rectangle is a square. Which pen shape has the greatest area?
All right, so if we go back in our time machine, let's think about what the area was for each. We've got 5 times 1, which equals what? 5. Then we've got 4 times 2, which equals what? Let me see if I can write it for you. No, here we go. All right, so we've got 5 times 1 for our area, right? And that equals 5. So then for our second one, we do our area of 4 times 2, which equals what? 8. And then for our last one, what two numbers are we going to multiply to find the area? 3 times 3, which equals what? 9. So which pen has the greatest area, the pink, the orange, or the purple? The purple, right? Because it is 9 feet. The inside is 9 feet. All right, let's see if I can get it to play for us.
The square pen shape has the greatest area. Now you know how to compare rectangles that have different areas but the same perimeter.
Okay, guys. So let's go ahead and we are going to do quite a bit together and then you guys will do some on your own. So you are going to need your volume 2 math book and you are going to want to turn to page 627. 627. Okay, I'm gonna make that bigger for you. And remember, it always makes me do it 2 times. So you should have that page now, 627. All right, so a lot of it is wanting us to use grid paper, and I know we sometimes don't have grid paper. So we are going to go ahead and actually start with number 11. Okay, so you are on 627, and we're going to go ahead and do 11. Let's read the directions. It wants us to write the dimensions of a different rectangle with the same perimeter as this rectangle, or this rectangle, or this one, or this one. Then tell which rectangle has the greatest area. All right, so the first step we want to do is we want to find the perimeter. Then we will figure out the area. So let's think about this. We have 4 and we have 5. We know the opposite side of a rectangle is the same length. So now let's make sure we put 4 here and across this way. If this is 5, what's this? 5, right? So how do we solve the perimeter? Remember, we add every single side together. 5 plus 5, which we can put in our head is what? 10. And then we have 4 plus 4, which equals what? 8. So our perimeter has to equal what? It has to equal 18. So we need to think of another shape that can have the same perimeter, but it has to have different numbers. So this is where you're going to have to really think and use your addition to help you. Okay, so let's go ahead and draw another rectangle. And let's do, mine kind of looks like a square. Let me make mine a little bit longer. You don't want squares. So go ahead and draw your rectangle. And let's do maybe 6. So if this is 6, then what's this side going to be? 6, right? All right, well, let's stop and think, what is 6 plus 6? 6 plus 6 is 12, right? So how much more do we need to get to 18? Let's see, 12, 13, 14, 15, 16, 17, 18. So altogether we need 6 more. So we can't put 6 and 6, but if we were to split up 6, how could we split up 6? Can we divide 6 divided by 2 sides? What is 6 divided by 2? Or what plus what equals 6? 3, right? So now 12 plus 1, 2, 3, 4, 5, 6 is also going to equal 18. So we have the same perimeter, but the question they want is for us to tell which rectangle has the greatest area. So remember, for our area, we're going to multiply our two numbers. And this is where I'm kind of running out of room. So for our area for the first one, we're going to say 5 times 4 equals what? 20, right? What would we do to figure out the area here? Go ahead and write that down. You could even write it inside your rectangle. We're going to multiply 6 times 3. And what does 6 times 3 equal? 18, right? So they want us to tell which rectangle has the greatest area. Well, the purple one has 20 inches, and the green one has what? 18 inches. So if we were to pick, which one would we pick? Is 20 or 18 inches greater? 20. So let's go ahead and just circle the answer. Okay? All right, let's go ahead and do the next one. So we have 4 and 3. So we know the opposite side has to be the same length. And if we were to add our perimeter, we need to add and figure out all 4 sides. So we know 4 plus 4 equals what? 8. And then what does 3 plus 3 equal? 6, right? And then what is 8 plus 6? 8, 9, 10, 11, 12, 13, 14. So our perimeter for the next one also has to be 14. So go ahead and make your rectangle, not a square. And let's think about what could we do here. Okay, well, let's think about 14. I always like to use 10s. Is there something we could do to make a 10 here? What plus what equals 10? 5, right? All right, so 5 plus 5 equals 10. How much more do we have to add to 10 to get to 14? 4, right? What could we, so we can't put 4 and 4. Remember, we have to split that 4 up into 2 sides. So what plus what equals 4? Or 4 divided by 2 equals what? 2, right? So now we have 10 plus 4 equals 14. So now let's think about our area. Remember, we multiply 4 times 3 equals what? 12 feet. And then on our other rectangle, what two numbers are we going to multiply? 5 times 2, which equals 10 feet. Which one has a greater area? Circle it. You should have circled the orange one. All right, moving on. Hopefully it's getting a little bit easier for you. Let's go ahead and label our sides. And we know 9 plus 9 for our perimeter equals 18. And then we have 5 plus 5, which equals what? 10. So our perimeter has to equal what, guys? Our perimeter has to equal 28. So how can we do that with our new rectangle? Okay, well, let's think about our 10s and our 1s. Could split it up. How many 10s are there? 2 10s, right? 2 10s, 2 sides, right? 10, 20. Does that take care of that? Yeah. So then what do we have left? We have 8 1s left. So what plus what could equal 8? Because remember, we have 2 more sides. What could we do? Oh, 4 plus 4. That works, right? So we know that equals 28 because we know 20 plus 4 plus 4 plus 4 equals 28. So now let's do the area. 9 times 5. And what would our area be here? 4 times 10. Go ahead and solve both of those. 9 times 5 equals what? It equals 45, right? And 4 times 10 equals what? 40 centimeters. Which one has the greater area? It always seems to be the first one. All right, I want you to take a minute and I want you to think about how we are going to figure out the perimeter for the green. You should be writing in the other sides. That's our first step. And then we're going to add them together, right? 5 plus 5 equals 10. 3 plus 3 equals 6. So our perimeter for both has to be what? 16. Let's go ahead and draw our rectangle. And how can we split up 16? Well, let's think about our numbers. We've got 1 10 and we've got 6 1s. So how can we break apart 10? What plus what equals 10? 5, right? And then what plus what equals 6? 3. So we know 10. Oh, wait. Hello, Mrs. Harp. What did I do wrong? I'm writing the same one. So that trick's not going to work. We're going to have to change that. What could we do instead? What could we do instead? What else could equal 16? Could we do, what else could we do? Could we change it maybe to 6? Let's do 6. 6 plus 6 equals what? 12. And we need to get to 16. So 12 plus what equals 16? 12, 13, 14, 15, 16. All right, so 4. We need 4 more. Well, what's 4 divided by 2? 2, right? So 2 plus 2 equals 4. All right, sorry if I totally lost you for a second. All right, so now let's solve. 5 times 3 equals what? 18. And 6 times 2 equals what? 12. Go ahead and circle which one has the greater area. There you go. All right. Hopefully you are not too lost. I am going to have you work on, in your additional practice book, page 203. I want you to answer 5, 6, and 7. Okay, you're doing the same thing. You're going to have the same perimeter. Find your perimeter first, and then find your area. Okay, guys? All right, we'll talk to you soon.